Hello, welcome again. We are covering the topics axial flow compressor for civil services MECH, IFS and GATE Aerospace exam. And next subtopic in this main topic of axial flow compressor is basic operation of axial flow compressor. So this is your typical two-stage axial flow compressor. And in this, there first is rotor blade, then there is stator blade, then rotor, and then stator. Okay. And rotor blade imparts kinetic energy to the flow of air that is coming into the compressor. It also increases the pressure, static pressure of the air. So rotor blade imparts energy in form of kinetic energy as well as in form of pressure energy. But in the stator part, no energy is imparted. Only the kinetic energy imparted in the rotor blade is changed to pressure energy. Okay. So this is the basic operation of the axial flow compressor. It is almost same as that of centrifugal compressor, but with one difference. Here the flow takes place in axial direction, and there are many stages. So, so I will read it and explain each and every point whenever needed. First point is the axial flow compressor consists of a series of stages, each stage comprising of a row of rotor blades followed by a row of stator blades. The individual stage can be seen in figure 1. So this is your stage, this is rotor, this is stator, and this is again rotor, this is stator. So this is two-stage axial flow compressor. Next point, the working fluid is initially accelerated by the rotor blade, this blade, and then deaccelerated in the stator blade, and then deaccelerated in the stator blade, where in the kinetic energy transferred in the rotor is converted to static pressure. Kinetic energy transferred by the rotor is converted to static pressure. The process is repeated in as many stages as are necessary to reach the required overall pressure ratio. So the process, here there is two-stage compressor, it can be three-stage compressor, four-stage compressor, depending upon the overall pressure ratio required. Next point, the flow is always subject to an adverse pressure gradient. So it means here we can see that kinetic energy is increasing and flow is taking place in this direction, as well as pressure energy is increasing, and here also the pressure energy is increasing. Okay. So the flow is taking place in this direction. So flow is always taking place in a direction in which the pressure is increasing. But actually what happens, if there is no compressor, the flow always takes place in a direction in which the pressure is decreasing. But here the pressure is increasing and flow is taking place in this direction. So that is your adverse pressure gradient. The flow is always subject to an adverse pressure gradient, and the higher pressure ratio, the more difficult becomes the design of the compressor. As if there is very high pressure ratio, then the design of the compressor will become more difficult, because then we have to make more effort to make the flow in the direction of adverse pressure gradient. Next point, the process consists of series of diffusion both in rotor and stator blade process. Diffusion means pressure rise. Okay. Although the absolute velocity of the fluid is increased in the rotor, it will be shown that the flow relative velocity to the rotor is decreased. So here absolute velocity is increasing, but relative velocity will decrease. That will increase the pressure of air. The pressure will increase at the cost of decrease in relative velocity, but absolute velocity will increase. The process consists of a series of diffusion both in the rotor and stator brake presses. Although the fluid velocity is increased in the rotor, it will be seen that the fluid velocity relative to the rotor is decreased. That is, there is diffusion with the rotor presses, so there is need for moderate rate of change of cross section area of in the diffusion. So as uh, here the pressure is increasing, velocity is increasing, so we cannot have the same area at the inlet and at the outlet. So for compressor, this type of configuration should be there for the blade. So here we can see the gap is small and here the gap is large. So diffusing passes or diverging passes should be used for compressor blade. And this is for turbine. Here the gap is large and here the gap is small, so it is used for turbine. Next point is the limit of diffusion in each stage means that a single compressor stage can provide only a relatively small pressure ratio and very much less than can be used by a turbine with this advantageous pressure gradient, converging blades, passes and accelerating flow. This is why a single stage can drive a large number of compressors. So in a single stage of compressor, there is very small pressure rise, and that pressure rise cannot be used to run a turbine. Or that pressure rise is too small for the turbine. Okay. For the turbine, so it means a single stage turbine would drive a stage of sorry, a single stage turbine will drive a compressor of having large number of stages. Okay, so that the some pressure can be built up for the turbine to run. Okay. Next point is careful design of compressor blading based on both aerodynamic theory and experiment is the careful design is they are based on aerodynamic theory, and experiment is necessary not only to prevent the wasteful losses but also to minimum the stalling problem. The next problem in the compressor is your stalling problem. So that we have studied in the centrifugal compressor. So at a large angle of incidence, the breakdown of flow occurs uh, and the reversal of flow can take place. Okay, so this is a styling problem. So the blade should also be designed for that also. Okay. Which are all too prevalent in the axial compressor, especially if the pressure ratio is high. Styling is, as in case of isolated airfoil, arise when the difference between the flow direction and the blade angle, that is angle of incidence, becomes excessive. The fact that the pressure gradient is acting against the flow direction is always a danger to the stability of flow, and the flow reversal may easily occur at the condition of mass flow and rotational speed, which are different from those for those which the blade are designed. And next point is the inlet guide vanes is an additional stator rope upstream of first stage and serves to direct axially approaching the flow correctly into the first row of rotating blades. So here there is one stator blade or inlet guide vane that directs the flow to the rotor. Next point is for a compressor, a row of rotor blade followed by a row of stator blade is called stage. Two forms of rotor have been taken up, namely drum type and disc type. So disc type is used when the low weight is most important. So